Hi everyone, in today's lesson I'm going to talk about how to use U substitution with trigonometry. So let's write down that as our topic. Now, before we can talk about U substitution with trigonometry, I'd like to just review what this sine, cos, negative cos acronym stands for. So going to the right is our derivatives, and going to the left is our antiderivatives. All right, so it's important that you know this when solving trig integrations. So I'd like to do example number 1, which is something that we've done before. Say I want to ask you to take the integral of cosine of x dx. So we've done this before where you say, okay, I want to find the integration of cosine. So I look at cosine and I go back and my answer is sine. So my final answer is just sine of x plus c, right? Now this example is very easy because there was no need for U substitution. So what I'd like to do now is show you an example where U substitution would be necessary. So example number 2 we'll say is the integration of cosine of 4x dx. So on the top, I'm just going to write sine, cos, negative cos again. And now you should be noticing that there's a 4x inside those parentheses. So because there's a 4x, we're going to have to use U substitution. So kind of like we did before, we're going to let U equal what's inside the parentheses. And then follow the same steps. Step 2 would be to find du, and same thing as before, step 3 will be to solve for dx. So, step 1, u. I'm going to let u equal 4x, and I'm going to find du, my derivative of u. Well, we know the derivative of 4 times anything, or 4x, is just 4 times dx because we're taking the derivative with respect to x. To solve for dx, we divide both sides by 4. So dx is du over 4. So now that we have all that information, we can go ahead back to our original problem and substitute back in. So we want to find the integral of cosine of now u, and then plug in what dx is equal to. So we're going to times it by this. This is what dx is. So du over 4. So what you can see is that we almost can integrate this now because it's cosine of u du, but we have this over 4 that's kind of just hanging out there. So you have an option to kind of make it 1/4 because it's a 4 on the bottom. So you can make this as 1/4 times cosine of u du, right? Because anything divided by 4, right, is the same thing as 1/4 times that number. And then we can kind of do what I did in those other problems. Take this constant, bring it on the outside. So I have 1/4 times the integral of cosine of u du. And the integral of cosine, right up here, we're going to go left, is sine. So it's sine of u plus c. And then don't forget the 1/4 that goes in front. And then all we have to do is put u back in. So my final answer is 1/4 sine of 4x plus c. And that's it. That's a integration with trigonometry using U substitution. All right, let's try another problem. Okay, so let's call this example number 3. Let's say I want to integrate 60x to the third times sine of 5x to the fourth dx. So this one's a little bit more complicated because I've added some numbers in front as well as stuff inside the parentheses, but the concept is still going to be the same. We're still going to let u equal what's inside the parentheses. So u is still 5x to the fourth. And we still need to integrate we still need to take the derivative. So the derivative of 5x to the fourth is 20x to the third dx. We still have to solve for dx by dividing. So we get dx is du over 20x to the third. So now all that's set up, we substitute back in. So we have the integral of 60x to the third times sine of now u, and plug in dx. This is what I let dx equal. So du over 20x to the third. Now what you should notice is that these x to the thirds are going to cancel out, right? This x to the third with this x to the third. And we can divide the 60 and 20. That'll give us 3. So we have the integral now of 3 sine of u du. We can do what I did before, and we can pull out the constant. So 3 times the integral of sine of u du. Now this brings me back to our sine, cos, negative cos. And I want to take the integral of sine, which is here, and I have to go left. But going left just brings me back around to negative cos. So our integration is negative cos of u plus c, with not forgetting that 3 in front that I have to multiply. So putting it all together and substituting the x values back in, my final answer is negative 3 cos 5x to the fourth plus c. That is my final answer. Okay, so we'll call this one example number 4, and I want to do a little bit of a harder problem. So we already have information about sine and cosine when we use that acronym. So we really don't need this one and this one. But these other ones, the derivative of tangent is secant squared. The derivative of cosecant squared is negative cosecant cotangent. These rules will be something that you need to write down. So if you want to pause the video or even take out those yellow sheets that I gave you, if you still have them, these are the integrations that we're going to need to know. So example number 4 will be secant squared. So let's do an example with secant squared. So we have the integral of 12x squared times secant squared of x to the third plus 3 dx. So the same kind of concept as before. We're going to let u equal the stuff that's inside the parentheses. So u is x to the third plus 3. du, we take our derivative, which is 3x squared times dx, and then we solve for dx. So divide by 3x squared. So dx is du over 3x squared. Then we go back and substitute our stuff back in. So the integral of 12x squared can stay times secant squared of now u times dx, which is du over 3x squared. So just as we did before, we can notice that this x squared and this x squared will cancel, and we can divide the 12 and 3. So when we do that, we get 4. So we want to integrate 4 secant squared of u du. Again, we could take out this 4 if we'd like. So 4 times the integral of secant squared of u du. So now you want to take a look. If the derivative of tangent is secant squared, then the integration or the antiderivative of secant squared will simply be tangent. So leave the 4 as a multiplication. So it's going to be 4 times tangent of u plus c. And then we just plug in what u was. And u was x to the third plus 3. And don't forget your plus c. This should be our final answer. All right, I'd like to do one more question that's a little bit harder, and we'll end the class at that one. Okay, number 5. We'll integrate negative 45 x squared cosecant 5x to the third minus 4 cotangent of 5x to the third minus 4 dx. So this one's a little bit longer, but you should be able to recognize that it's cosecant cotangent, which is this one. So if I want to take the antiderivative of this, it'll just be cosecant of x. And there's the negative there as well, so that's perfect. So we're going to let u equal what's inside the parentheses. So u is 5x to the third minus 4. Du is my derivative, 15x squared dx, and divide by 15x squared. So dx is du over 15x squared. So now that we have our setup, we can go ahead and plug it back in. So I want to integrate negative 45x squared cosecant of now u cotangent of u, and then times dx, which is du over 15x squared. So what's pretty cool is the x squareds cancel. We can divide 45 and 15. That'll give me negative 3. So let's write that as the integral of negative 3 cosecant of u cotangent of u times du. Now, since I want negative cosecant cotangent, I'm actually going to take this 3, only the 3, and move it to the outside. So I have 3 times the integral of negative cosecant u cotangent u du. And then I take a look, negative cosecant cotangent, the antiderivative is cosecant. So the final answer will be 3 cosecant of u plus c. And then last but not least, put the u back in. So 3 cosecant of 5x to the third minus 4 plus c. This is your final answer. All right, that's it for the day. If you have any questions, please let me know. Have a good one.